Hello, and welcome to the Cybersecurity for Next Generation Connectivity Systems series. It's an activity sponsored by Mission Critical and IEEE. Thank you for joining us for the session today. And there'll be a series of sessions that go at least every week during the Cybersecurity Month of October. I'm Don Davidson, Executive Director for Mission Critical. Many of you know me from my supply chain risk management activities. The last 15 years in the federal government focused on ICT and cyber supply chain risk management. I'm happy to see the adoption of supply chain in many aspects of cybersecurity. And you're going to hear about some of them today from Lourenço, Dr. Lourenço from Aeronautics Institute of Technology, ITA Brazil. He is a professor of computer science at ITA. Over to you, Lourenço. We're going to have a short intro.
Please let me know if you're seeing my screen.
Perfect. Perfect.
Yeah. Thank you for the introduction, Don. Today we are talking about security open ecosystems and supply chain next generation connectivity systems. My name is Lourenço. I'm professor of computer science division at Aeronautics Institute of Technology in Brazil. We're located in São José dos Campos in Great São Paulo city area. I work with cybersecurity systems and networked systems. I focus on attack and defense of critical infrastructures. I'm also head of the laboratory called Command and Control and Cyber Defense. Here is our motivation. When we see the service we are developing and providing to our digital society nowadays is getting bigger and bigger and more complex because we have a lot of vendors, a lot of interfaces, standardized interface, distributed integration, and the attack surface is getting more complex and bigger. So we must provide a movement from implicit trust to a measurable trust. Our core principle here is security has architecture part of our solution, and it must be observable and verifiable property. So in that context, the core principle here is trust must be observable, measurable, and automated. We must be driven by the evidence, what happens in the real systems. For example, the telemetry must be trustable, signed. We must be get that attestation of what happens in remote, and also get trails that must be auditable, and so on and so forth. Integrity must be a continuous flow, not only a single isolated event. One example of such a system is Open Run. Open Run is a complex and modern systems that are has a lot of risks involved in deployments, in firmware, and also unauthenticated APIs, OPEC modules, so on and so forth. So we must see everything. Again, we must have a directive for explicit threat model per interface there. Here's an example of the distributed nature of the run deployment with a lot of components near to the users, a lot of interface to communicate to everything in those components. In that sense, when we make a deployment of Open Run, we must be aware of segregation, least privilege principles. We must take care of signature verification, all of everything there, runtime isolation, and also unified observability. Sometimes it's easier to say those things, but very hard to implement that correctly in a deep sense to make the systems more secure. Here again is an example of deployment. And what we have here is a multiple vendor architecture. The whole chain of solutions pertain to different multiple vendors. Indeed, here towards the core of networks, we have a lot of different players, different solutions there. So again, we need to be aware of segregation and less privilege on each of those components, we must be aware of the signature, verification of those signature, runtime isolations, and logs, and provenance, where they came from, the cross-domain correlation in that context. With a lot of vendors, with multiple vendors, we lay on the ground where we have a supply chain, a chain of different providers for software, and all the whole inventory of components and dependencies we have there. SBOM take us to that consciousness awareness. And VEX, it's about vulnerability exploitability exchange. See what are the vulnerabilities most likely to happen in that context, and also supply chain levels of software artifacts to see the provenance of those artifacts and that integrity. By the end of the day, SBOM, it's about what we have deployed, what are our assets. Inside those assets, what are the vulnerabilities? VX take care of this, and also SLSA take care about the trust in that environment. We must create integrity pipeline where information from SBOM serves as ingestion to see what are the common vulnerabilities and exposures we have there, correlates that with what we have inside of our deployment, what is exploitable, so we can issues new procedures to make the deployment more reliable, the hardening process in that context. So the continuous integrity pipeline, build the release with provenance, we must have a lot of integrity in that sense. Monitoring, we must be aware of telemetry logs, and also drift. When we have new deployments, new updates, and different configuration that system, sometimes a configuration deployment that is working after the updates does not work anymore. In that sense, we all need a response team for that. Again, it's not a battle, a single-man battle. It's a task. It must be a task force where we have a platform for sharing. We have internet service provider organizations that had a lot of information there. With again, with AI, most advanced solutions, and share with other organizations to make a task force to fight against the threats we have. Okay, but for implement those updates, to implement the change, we need the trustable sources. We need assigned firmware updates. That's because it's easy to, if you not get assigned firmware updates, someone, a third-party malicious one, can run arbitrary codes on your infrastructure. So we have a lot of, we need to have a lot of resources that says. How we can improve that? By getting identity and life cycle to guarantee those signatures up to date, those signatures, the whole chain of suppliers must be signed, so on and so forth. And we must have some kind of resources to include and also delete. In other words, revoke the Revocation and Security Commission of end-of-life product, end-of-life updates and piece of software we have there. The indications here, we have a verification of flare rates, revocation events. We also have a vendor risks and measurable assurance. Again, we need more cryptographic schemes and protocols to improve that that chain of trustability in our deployments. Use case, for example, when we have a selection, we must have a set of prerequisites to incorporate new solutions. During the onboard, check how we can bring new suppliers there, penalties and incentives in the contracts. Cyber, how we must, again, here we have put again that picture here, because not only provide our internal security, but we need a task force in that sense to share those commonalities, the risks, and the supplier that maybe in the future become not trustable. We can share these things, and new threats that eventually arise, we also be aware of those things. Okay, so challenge. We must start wide or deep. By experience here, we have a view of start wide and get deep when we need. Eventually, everything must be go deep, but we must start in some way that a top-down approach where leaders and the decision makers can decide, can be aware from the principle from the start about the cybersecurity. Criteria for providers, again, we must be state a series of steps where we guarantee those suppliers are reliable in the future, reliable in the past, and during the onboarding process. And also, we must be aware of the risk management and the inventory. We must take a more active posture against those threats and see in real time what is happening. Okay, for our final thoughts, openness is structural, is changing the way we deploy systems for the last decades, for the last new technologies we are rising. We must have a set of measurements, verifiability, traceability indicators, and we have a convergence where we have the threat modeling, the scan what happens in our infrastructure, and then how these impact in the whole supply chain, chip chain of service, internet service providers and softwares we have deployed there. Okay, cybersecurity is binding together technology, process, and people. Our ultimate goal here is provide reliable services and applications to our society for the new generation of communication systems.
Thank you so much, Dr. Lourenço. That's excellent. It's good to see that a lot of the lessons learned that we have with supply chains over the years from the early 2000s is actually bearing fruit in practical application. As you talk about going wide and deep with supply chain, gaining introspection into where the hardware, software came from, where the data is coming from, what are your sources, do you trust the hardware, trust the software, how do you score that and work through that? These are all things we see maturing. Thank you so much for your presentation. Thank you for your time, for those that have participated in this and other series that we provided throughout the Cybersecurity Month. And before we close, I'd like to point you for the quick review of the fact that this is week of October 20th, and this is our topic for this week, but the week of October 27th, it will be the future for secure connectivity. Thank you so much.